before watching this lesson, let's make sure that we've watched both of the factoring trinomials lessons, because we're building off of that knowledge here with a pattern of factoring that is called the difference of two squares. It's essentially a shortcut, a formula, and a pattern that we can use to take shortcuts and use this formula and do some quicker factoring. Now, you're only going to be able to use this formula when you have a difference of two squares. So you have to ask yourself, are there two numbers that I'm subtracting, and are both of those numbers perfect squares? Now, what do we mean by perfect squares? Well, perfect squares are the numbers that are squares of other numbers. So 1 squared is 1. 2 squared is 4. 3 squared is 9. Do you see where I'm going with this? 4 squared is 16. All of these numbers that are the squares of other numbers are called perfect squares. So it might be helpful to look up a multiplication chart, potentially the one I've posted in Google Classroom, so that you can see all of the perfect squares down the diagonal. Those are going to be helpful for us today. Now, the pattern that we're going to use when we have a difference of two squares, a squared minus b squared, two squares that I'm subtracting, is that we can very quickly just say, okay, well, it factors to a plus b times a minus b. And that's it. We don't have to do an X puzzle. We don't have to solve it. We don't have to do swinging and dividing. We know that this pattern or this formula exists. Let me prove it to you. So we have this problem, x squared minus 49. And I'm going to solve it, I'm going to factor it with an X puzzle. A times c goes to the top. That's 1 times 49. And 1 times negative 49 is negative 49. There is nothing in the center, so I'm going to put a 0 in the bottom. And my a value is 1. Now, the numbers that multiply to 49 are 1 times 49 and 7 times 7. Luckily, if I use 7 and negative 7 in my X puzzle, I'd be able to quickly say, all right, 7 divided by 1 is 7, negative 7 divided by 1 is negative 7. We bring these puppies down. This is x plus 7 and x minus 7. Now, there's nothing wrong with doing that. That is a correctly factored polynomial. However, if you notice that this is actually a difference of two squares, meaning that you have two things that you're subtracting and they're both perfect squares, we can make this way simpler. Do you recognize that x squared minus 49 is the same as x squared minus 7 squared? Okay, that means that we can follow my pattern that's right up here. The first minus the second, the first plus the second. The first minus the second, the first plus the second. Bing, bang, boom, I'm done. This formula, called the difference of two squares formula, is a quick way to factor these specific polynomials. Again, but they are only the ones that have two numbers that you're subtracting, and both parts can be written as perfect squares. We just have to practice, okay? Pull up that multiplication chart if you don't know your perfect squares, and let's start factoring the first 6. T squared minus 81 squared. I'm really hoping that you notice that 81 is on my perfect squares chart. It's 9 squared. So I know that this is going to be t minus 9, t plus 9. That's it. I'm done. I've already factored it. If I wanted to factor r squared minus 64, hopefully you'd recognize that this is r squared minus 8 squared. First minus second, first plus second. Those are my factors, r minus 8 and r plus 8. Now you look at number 3. I'm going to have you pause the video and decide if these are a difference of two squares and then factor. Hopefully you notice that this 16 minus x squared is actually like 4 squared minus x squared. So again, I can very quickly use the difference of two squares formula to do first minus second, first plus second. And that is a correctly factored version of that polynomial. It is that simple. It is a very simple formula that is used to shorten these problems for us. If we look at number 4, though, number 4 is really, really interesting to me Because at first instinct, you might be like, all right, Miss Quigley, you said it's two things, check, that I'm subtracting, check, that both are perfect squares, but like, this has a coefficient. It does have a coefficient, but check out what that coefficient is. 4 is actually 2 squared. So really, we're like saying 2 and g squared minus 1 squared. So this pattern still holds up. First minus second, first plus second. I factored it. Again, I could be doing an X puzzle for any and all of these 6 problems, but it is just significantly easier to use the difference of two squares formula. Pause the video. I want you to try number 5. Factor number 5 using the difference of two squares formula. Here we go. 36x squared is like 6x squared minus 11 squared. So I can very easily factor this into 6x minus 11, 6x plus 11. Now if you look at number 6, something's wrong here. Remember, we said that we can only use the difference of two squares formula if we have two things, which we do, but it's literally called the difference of two squares. This is adding. So this is not a difference of two squares problem. I'm going to use the shortened dots because I can. Not a difference of two squares problem. Now, sometimes the difference of two squares formula is going to be used after doing another step of factoring. If we check out number 7, on first instinct, you'd say, Miss Quigley, those are two things. We are subtracting, but 2 and 18 are not perfect squares. And I would say that you're right. But if we looked for the GCF between 2x squared and negative 18, the GCF would be 2. So if I factored out that 2, the way we learned to do that with the leftovers, this would be x squared minus 9. Now what do you notice about x squared and negative 9? Yeah, these are a difference of two things that are perfect squares. So we can now use the dots formula, the difference of two squares formula, to do the first minus the second and the first plus the second. Now you might have heard me just say the first minus second, first plus the second, and write it the opposite direction. Remember, with factors, it doesn't matter the order in which you list them. So I could put the first parentheses first and the second parentheses second, and it doesn't matter the order. It does matter, though, that you have that GCF. Let's look at number 8. Again, it is two things. We are subtracting, but 3 and 48 are not perfect squares. However, factor out the GCF first, then you might be able to factor using the difference of two squares formula. Voila. If we factor out the GCF of 3, we then are left with x squared minus 16, which is really x squared minus 4 squared, the difference of two things that are perfect squares. So I take x and 4 and create first term minus second term, first term plus second term as my factors. And we factored the following. Now number 9 and 10 are just a little bit of bonus here. It says write the following factored form expressions. Okay, factored form because they have the parentheses. Those are factors. Write the following factored form expressions to the difference of two squares form. Okay, do you notice that this is first minus second, first plus second? Instead of having to actually multiply all of these out using FOIL or Punnett squares, I'd be able to think, okay, this is like 3t squared minus 9 squared, because it follows the pattern. 3 squared is 9, t squared is t, and 9 squared is 81. I'm essentially working backwards. Again, we notice on number 10 that since we have the first thing and the second thing, only thing changing is the signs, this is the difference of two squares pattern. So let's work backwards. This is going to be like 2x squared, since it's a perfect square, and 6 squared. We subtract in between them. 2 squared is 4, x squared is x squared, and 6 squared is 36. So 4x squared minus 36 is the polynomial that would factor to this pattern from the difference of two squares formula. Like I said, this formula is just a little shortcut. We are able to do every single one of these problems using an X puzzle like we've been practicing. It will just be easier for you if you notice that you have difference of two squares to go ahead and take that shortcut. Make your life easier. We'll keep practicing in class.